Hi everybody, my name is Jago Macleod, and we are going to talk about an interesting and emerging aspect of the public cloud especially, and I'm super excited. Is that the right direction? Okay, so the cloud has basically come full circle, and it's a really interesting moment. There was this beautiful vision of the cloud. It was this magical endpoint in the sky. You would just call it. It would provision things. You never had to know about any of the underlying infrastructure, and you just pay for what you want. And so we started out many years ago, and it was data centers, right? It was all about data centers. You would rack and stack, and you had to think months and months in advance and buy things, and they get shipped. There's that beautiful smell when you unbox a machine and you breathe in that air as it's off-gassing, and you get to plug it in and rack and stack it, and you get really like finicky about how you laid out your cables. And we all took great pride in that, right? But it was really challenging. You had to think months, years in advance for capacity planning. And when someone on your team, one of your teams wanted more capacity, they had to let you know. You had to put it in this big spreadsheet. They would think, oh, you know, I made games at Disney for a while, and they would say, it's going to be the next Candy Crush. We need 1 million machines. And you'd kind of, well, do we though? And so you had this sort of like mental linear regression analysis about the optimism of your product teams and how much you would really need. And then you had this portfolio view. And then we sort of moved along, and we got to this elastic cloud that was super awesome, right? We went through VMs. You could provision a VM in minutes, hours maybe, instead of months. And then you go into the cloud, and you don't even have to think about the machines. And finally, we get to now. And now we've sort of come full circle, and here's why. Going back to the very beginning, we would over-provision. You were like, okay, I know you're not going to do exactly what you say, product team, but I also know that I don't want to get in trouble if you do. So we would buy more machines, we'd plug them in, and then everything's running at 15% utilization. You're like way over-provisioned, and Black Friday's coming, so the rest of the year you run at 3%. And so VMs made this much, much better. We could spread VMs across. There was like OpenStack and what was it, Cloud Stack, and these were amazing, right? You could then spread the hardware. You could steal from one to pay another, and it was pretty great. And so it was kind of the shift was from CapEx to OpEx. And it was pretty fantastic to not have to do all the depreciation and all these things. And the other thing about the cloud was that it was just infinite, right? You never thought about the machines. Like AWS, Google, Microsoft, these places just have so many machines. There's nothing, I'm not doing anything like that. And it was just fantastic. I really enjoyed it. It was really easy. It was really fun. The cost was excessive. I went through a migration from on-prem to the cloud, and then got shocked, and then migrated back to on-prem. And the best you can do is what you already had before. And you lose people, and they're miserable, and you pay for both while you migrate. And it was just kind of a terrible situation. So what happened to this magic moment? What happened was fragmentation. All right, when we started Google Cloud, we had one instance type. AWS had a handful of machine shapes. And a node is a node is a node. It has CPU, it has memory, it could have more, it could have less, but the workload pretty much runs the same on it. You don't really care as a workload operator. And today, we kind of have these ARM chips that are awesome. If you haven't tried ARM, it mostly usually works. Try it out. If it doesn't, it might take you infinity time to figure out why it doesn't work. So I would say don't go down the infinity rabbit hole right away. But it's pretty great from an efficiency perspective and power management, and it's a wonderful architecture. But you do have to compile your application into multiple architectures, and there's complexity. There's also accelerators like GPUs and TPUs, and they're kind of scarce and they're specialized and they're spread out. And so it is, even the version, the drivers, like you actually have to think about all these things in a way that you haven't in years. This is what I would think of as the end of uniformity. And then the other is the explosion of regions and regionalization. And so Amazon has kind of always been this way, but GCP is also becoming a lot more regional isolation. And so you not only have to think about the machine shape, but also what region it's in and whether that machine shape is available in that region right now for you. And so how do we manage this? We manage this with reserved instances and committed use discounts, and they're sometimes by machine shape. If you haven't looked at flex CUDs in GCP, I am really happy when customers have flex CUDs because they're dollar-based, not machine-based. So then when we recommend you might want to try a different machine shape, you don't have the financial incentive to avoid it. And it also gives you some more flexibility in how you deal with this reality. So stockouts were a thing that we've almost never encountered a few years ago. There's sometimes a new region would spin up and a very big customer would move into a very small region. And there were moments when, I don't know, like very bright engineers put in, well, I don't know, if there's a runaway train, we want to limit, let's say we don't want any one customer to have more than 15% of some resource type in a region, and so put a limit on it. That was an actual OMG that we dealt with. No one could figure out what was kicking in. That was, we just look through and find someone just made up a number. 15% seems reasonable, but it was a very small region that was brand new, and it was a very big customer, and they wanted more. And I said, I can assure you how we make sure they spend 0% of that capacity is to not fix this bug for them. But this is real. So now you have committed use discounts. You make these reservations for 3 years. And where are you? Like right back where you tried to get away from, right? You have now you have unused capacity because you listen to the product managers with their ambitious goals of what they're going to do. And then you have this downturn, right? And in month 3 here, you have way more capacity than you need. So we have this constrained capacity, and the kind of big idea that I want to leave you with is instead of scaling infinitely horizontally, you kind of scale vertically in time, and you think about the priority of the workloads that you're running as a ongoing, ever-growing queue. And this is kind of a big difference from where we used to be, but it requires a check. Like user submits a job, and then you wait and you let them check. So it used to be you just squeeze us for discounts, right? And discounts drive me nuts. I tell the product team, never tell me about the discounts. It makes me feel like our work is less valued than I think it should be. High discounts. But you used to try and pay the least for what you need right now, and you run everything right now because it's infinite capacity. No one has to wait ever. You just scale horizontally. And instead, it's about utilization of reserved capacity at this point, which sounds a lot like a data center, right? So it's kind of a virtual data center in a cloud or multiple clouds, but the kind of the concepts that you used to use apply in many ways here as well. So Kubernetes has a lot of useful properties. You could use other systems to build something similar, but really what you want to do is declare in a single place and then use the world as your computer. And you need to stitch the world together in interesting ways. So there are some kind of upsides. So if you think about ambient global compute is this kind of catchphrase that I'd like to think about for application developers. They shouldn't have to know about any of the regions or the machine shapes, whether it's ARM or x86. You want them to say, run my workload. And then you as a platform admin or platform team say, okay, I'm going to run your workload when I can, where I can, how I can. So Topology-aware scheduling is possible in Kubernetes today. It's pretty hard with what's available in upstream open source Kubernetes. The managed cloud providers provide a little better approach to it. And there's a whole lot going on in this space. So watch this space in the next year. It's really about workload-aware scheduling and topology-aware scheduling are driving a lot of the work in the scheduling space. And we're kind of shifting from map on a pod to a node and shifting that to map a workload to some capacity somewhere. And that capacity changes. So you've heard all week about dynamic resource allocation and DRA and all this thing. One of the kind of critical benefits of DRA is instead of having to know this super specific driver and the vendor and all of this, you can know about, what do I need? Any high memory GPU will do. You pick it, you figure it out. And they're really finicky. I don't know if you're working with them today, but the version of the GPU driver, you actually have to change some of the abstraction leaks all the way through to the end user. So that's one of the primary benefits of DRA, is providing an abstraction that's Kubernetes native for this kind of workload. So it's kind of busy, but the key idea here is about compute classes in Amazon and Azure. It's Karpenter, but it's the same idea. And this gives you some flexibility, where you say, I want to use my reserved instances first because I already paid for them. And then there's this idea of spot instances, which are, if they're available, they're cheaper. It's the way we fill out our own excess capacity and sell that. But they could get preempted. So your spot instance can go away. Depends on the workload. Sometimes it's resilient to that, sometimes it's not. But it kind of helps fill in after your reserved instances. This is the next, what you want to use next. And then you kind of have this last resort, which is on-demand instances, which is what you would pay the list price for right now on demand. It's, the last minute flight to wherever you're going always costs more. But this helps a lot. So in a different visualization of the same idea, you want to start with what you paid for already. You're paying for it whether you use it or not. Then you go to spot instances, then you go. And this is kind of the way that the user experience is about expressing that intent and the conditional and how to fall back. So it talked about scaling vertically in time as a queue. And this is the key idea, is a queue, of course, with a K. But queue is, there's also Volcano. Pretty much any engineer who walks up to this problem comes up with a similar idea. So the ideas should resonate regardless of what the implementation is. But queue, we put a lot of effort into, and it's super useful. So you think about multiple jobs, and then you just put it in a waiting room. And there's the ideas about quota. There's team A, team B. Team A might have some amount of quota. You can say the research team has this much quota, the back office has that much quota. And the benefit of that is if team B has no quota, but team A isn't using the hardware right now, then team B can still get their workload run. And kind of all batch and HPC frameworks have a similar concept. Some are super sophisticated. The Slurm has like a multi-dimensional priority and preemption. It's like 20 years in and there's lots of knobs. But really it boils down to some of these core concepts. So you kind of have this tension, and everything we do is trade-offs, right? So it's that whoever's in charge of the spreadsheets tells you, we bought this hardware, we want you to use it all the time. And the product that says, well, when we want to use it, we want to use it right now. And so we have to kind of figure out how to manage these trade-offs. Well, this is another diagram, and I'm showing some of these concepts from a bunch of different ways. I find different diagrams resonate with different people, and some people like, I'm a sucker for a sequence diagram. Some people like this kind of diagram. But you see kind of this admission control is the kind of big idea. You have this batch job, you have a something that's really important. Sometimes it's the VLLM serving pod here is the higher priority, and it's going to preempt the batch training pod that is not as high a priority. And so then it gets re-queued. If it gets kicked out and it hasn't completed yet, then it just goes to the back of the line, and based on its priority and what the quota is that the team has, it will get back through. So again, you're running the most important workload to run next. And at every moment, you're kind of evaluating what's coming in. So another kind of challenge is capacity. And this team may know, I know how to schedule a workload in Europe, and there's no capacity, but I don't have the wiring to send that workload to the US, even though it could run there. And so this is another kind of pattern, and the way that we like to think about this is multi-queue is the extension of queue, where you have a cluster, which is kind of the admin cluster. You might run Argo has a similar concept where there's a golden cluster or a admin cluster. And so each of the other clusters is running queue, and they register with this central manager. And basically, the central manager broadcasts, I have a new job to run, and any one of those worker clusters can say, oh, I have capacity, I can run it. So now you kind of get to spread it across multiple regions or even multiple clouds. And the metaphor I like to use for this is this Tetris game. Okay, and there's a lot going on here. I'm gonna try and mirror, which I did not do before, and I can't really use my mouse over there. So hang on 1 second. We'll see if I can pull this off. But while that's happening, is it gonna, where'd my other? No, I lost it. How's that? Yes, okay. So you can see there's different teams in the colors. There's team A, team B, team C, and they all have quota. And some teams have more influence with the platform team. Maybe they know what you like to drink, and they sent you good bottles of whatever that was, and so you say you're gonna get more. And some team really made you mad last week because they didn't do what you asked them to, and they're insecure and they get less, or whatever your way of prioritizing. And some jobs are just urgent. They have to run right now. And so then there's the pink outline here is, this means a GPU is required. And cluster A in this diagram has GPUs, so you can schedule stuff. Now I'm gonna show you, it's gonna be a little bit overwhelming, but you'll get, you'll get the point. That's why I introduced this slide first, so you get the idea. And these are jobs. Each one of these Tetris shapes is a job. It has a duration and it runs to completion. Now, you might be using some of the capacity to run workloads which are not preempted, which are not batch jobs. They're maybe long-running jobs. They're your company's website or something that has to keep running. So let's see if we can do this. Okay, so multi-queue, we're getting back to the idea of multi-queue. There's a cluster up here, which is the central manager cluster. And then cluster A has the GPUs, and cluster B and C are just CPU only. Okay, it's a little chaotic, but we're gonna start it out. So you have tons of teams across the company, and they submit these jobs, and they get placed in all these different clusters. And you'll see it's the ones that have the GPU requirement always get routed to the GPU cluster. The ones that have CPU might use that one if there's enough capacity, it might claim, and they might go to the other two clusters instead. And if there's nowhere for something to run, somebody doesn't have, then it just goes into that same waiting room, and it eventually we'll wait for capacity to free up in one of the clusters. There's a little bit of fragmentation in our cluster, so you can't always place the biggest thing exactly where it wants to go. But like this is kind of the overall concept that instead of scaling infinitely horizontally, you want to think about vertical slices of capacity and route the jobs that you have into the place where the capacity exists. And this is a super deep topic. There's lots of documentation on it, but pretty much all of the solutions in this space have these same core concepts. And when I talk to lots of customers, this is the kind of thing that they're missing in their overall architecture, is how to route jobs to the place where I have capacity. Sometimes there's data. There's some pretty cool things like in GCP we have a thing called anywhere cache. So if you have a big model or some data that you need in a different region, you don't have to actually replicate the data. You can cache it, and it's available in that cache. So you might have to think about things like backend storage and how to route that. But this is a really powerful concept. This was the offline one, just in case that other thing didn't work. Okay, so you think about a couple of patterns, and I'm really interested to hear if you have patterns. Please find me afterward if you have other ones that you think about. But I like to think about this sort of global batch computer as this, never-ending cascade of new jobs coming in, and it might be more important than the things we're running right now, and it might be fine to wait its turn. Another is this sort of elastic platform on fixed hardware. And this is how you kind of get a little bit of, you get some benefit out of the cloud. And it's, you kind of think about this as oversubscription, and then you preempt. So it's another idea based on that kind of, the thing that you need to run right now might be more important than the thing that's already running. And so there's a bunch of these things that you want to stitch together in different ways depending on what your use cases are. The topology-aware scheduling is going to get a lot more powerful in the next year. I actually had to do some research in what's available in upstream open source. Kubernetes is not great right now, so it can be kind of complicated if you're using this and making this work for you right now. I would love to hear more about it. But there's ongoing conversations that I'm excited about how to get the scheduler to use the new information that's being broadcast by DRA and make this much more performant. And these big AI, especially training, but also inference workloads are really pushing the boundaries here. Kueue and multi-queue is really important in this whole architecture. Again, there's Volcano, there's a couple other options in that space, but the kind of ideas are the same. And then inference specifically, I didn't go into a lot of detail here, but gateway API inference extension and some of the stuff in VLLM right now for prefix-aware caching can really help with sending the request to where the information is already cached and improve your utilization of reserved capacity a lot more than it has been in general. So the idea that I'm trying to go for here is they haven't actually come full circle. I don't know if you all use this, but I used to use this thing CSSH, which was like you could open SSH into like 100 or 200 machines at the same time. And you type one command and it would just blast it out to like 200 machines. It was absolutely terrifying because you're looking at these tiny boxes and it would fail in like 3 of them and you had to figure out which one it was and then go SSH into that one. We're not doing that at least anymore. We have a declarative API, we have a way to manage this stuff, but those were fun days. And so here's my AI-generated final image. Was supposed to be, it's not a circle, it's a spiral staircase up to the promised land. Are you getting it? It's amazing, right? It's an amazing metaphor. And so that's the idea, that we're like, yes, we're retreading kind of the same areas, but we're at a different time. And there's this one kind of cool idea is that ComputeClasses or Karpenter that give you the ability to go from reserved instances to spot to on-demand is kind of like that, the burst capacity in the cloud as you move to the cloud, every exec has the same idea, right? This is going to be awesome. We can use our on-prem data center, and then when we need it, we'll just burst into the cloud. And then like the complexity of running an application across a private data center and the public cloud is just overwhelming for almost every organization, and it never really works. The same is true for a single application being served from multiple clouds is not really a great idea. But this is an idea of this spiral staircase is we actually get that burst capacity idea by using other sources of compute infrastructure that might cost a little more. But it actually works, and it's really great. So if you have other patterns that work, please find me. I'd love to hear about them and watch this space going forward. Thanks so much for taking the time today. I really appreciate it, and have a great rest of the show.